Here we have a regular hexagon. What we need to find is the angle made by these two short diagonals. This question illustrates a very important property of short diagonals. The diagonals of a hexagon can be classified into two, short diagonals and long diagonals. Short diagonals are the ones which connect alternate vertices, which means they just leave one vertex in between. That is why they are short. If you see BE, it has missed two vertices here. So this is a long diagonal. Out of the 9 diagonals of a hexagon, 6 of them are short diagonals and 3 of them are long diagonals. Now these diagonals come with many interesting properties. For example, if the regular hexagon has a side length of say A units, if each side is of measure say A units, then each short diagonal is going to be of measure root 3 A units, and each long diagonal is going to be of measure 2A units. But that is not the property we are going to see today. Today we are going to see that each of the short diagonals will split the connecting vertices, the connecting angles into 30-90 ratio, because each of the angles is 120 degrees, right? So what this short diagonal does is that it splits each of the connecting vertices into a 30-90 ratio. Now in this question we are dealing only with short diagonals. In case you are wondering what the long diagonals do, how they split the connecting vertices, then they split it in a 60-60 ratio. Each of this 120, each of these angles is 120, right? So the short diagonals will split it into 30-90 and the long will split it in the 60-60 ratio. So that is what you will see today, and that is how we are going to get our answer. So let us start solving. So what we are dealing with is a regular hexagon and two of its short diagonals. Any regular polygon is equilateral and it is equiangular, which means all the sides are equal. That means if AB is an A, then all of these sides is of measure A units, and each of the angles is going to be 120 degrees. Angle A, angle B, angle C, all of the vertices, all of the angles are going to be 120 degrees. Now start with triangle BCD. I will just remove this line segment here. What sort of a triangle do you see? It is an isosceles triangle. Each angle is 120, which means here you have an 120 degrees. Two equal sides means two equal opposite angles. That means if this is alpha, this is alpha, which means what? 2 alpha plus 120, the sum of angles of a triangle is 180 degrees, which means each alpha is a 30 degrees. So this small angle here is 30 degrees, but the whole of angle B is what? Each angle is 120 degrees. So if this is 30, then this angle has to be right angle, which is 90 degrees. Now consider the triangle BCA. For that, let me just remove this line segment that you see here. What sort of a triangle do you see? Again, you see an isosceles triangle. What is the measure of angle B? Each angle is 120 degrees. Again, two equal opposites, two equal sides means what? Two equal opposite angles. So that means we are just continuing the same way. 2 alpha plus 120 is 180 degrees. That means each alpha is going to be a 30 degrees. So the angle that you see here is going to be a 30 degrees. Let me put back that line segment. So we found out that both of these angles are 30 degrees. Now this whole of this angle C is a 120 degrees. This much is 30. That means What do you have here? This much is going to be 90 degrees. Now let me name this point as say O. Now come to triangle COD. What do you see here? A 90 degrees here, a 30 degrees here, which means the third angle, or in other words the angle COD. The third angle is going to be what? It is going to be 60 degrees. Now that is the answer we needed to find. This angle is 60 degrees. That is all for today. Assalamu alaikum.